Hello to all my dear friends. I am Urubashi Tiwari. I study in grade 10 in Laboratory Secondary Boarding School. As we know that the pandemic situation has affected a lot in the education sector, and due to this reason, many students in the rural areas are deprived of education. They are not able to gain knowledge. So today we have planned to provide you all as everyone with education, some knowledge about metrics, and we are going to discuss about solving equations through metrics. As we know, there are many types of equations including linear equation, quadratic equation, and so on. But today we are going to discuss about linear equation. It is also called first degree equation or straight line equation. The required equation which we are going to solve today are, let's suppose it as x minus 2y equals to minus 3. Secondly, we have the equation 3x plus y is equal to 5. As I have already discussed you about, it is the straight line equation. So you can even see that in this GeoGebra, which is the best application for mathematics, we can see that it is a straight line already formed. The intersection point of both these straight lines are the required values of x and y. We can see here that the intersection point of these metrics are 1 and 2. So the required value of x and y is 1 and 2. Now we have already solved it through a GeoGebra, which is a graphical method. Now we are going to solve it through Cramer's rule and matrix method. So through matrix method, it is also the similar way. We are firstly going to solve by supposing the required matrix as x minus 2y equals minus 3 and 3x plus y is equal to 3. Here we have the two equations, and now we have to set these equations in matrix form. Here we have the coefficient of x and the coefficient of y. For supposing the first matrix A, we have to firstly take coefficient of x and y. Firstly, in matrix A, 1, minus 2, 3 and 1. We have to manage the x and y coefficients accordingly. Similarly, we have the second matrix, which is x, and we have to take the variables here, and the variables in these equations are x and y. And lastly, we have to suppose the third equation, the third matrix, which is minus 3 and 5, and this only includes the constant parts. Now we have a condition which is ax is equal to b. How do we get these equations from, friends? So I have made a note here, which is A inverse ax, and that is identity matrix and x, and finally we get it as x is equal to A inverse b. Now we have to find the determinant of A. For finding the determinant, we have a matrix which is A, and it is composed of the components 1, minus 2, 3 and 1. Firstly, what we have to do for finding the determinant is we have to subtract the minor diagonals from the leading diagonals. So in this matrix, the leading diagonal is 1 and 1, and the minor diagonal is 3 minus 2. While subtracting these two diagonals, we get the required value of A determinant is 7. It is not equal to 0, so it is possible to find the inverse. See, I have even made a second note, which is if there is 0 in the value of A determinant, there is no inverse and have no solution. Now moving forward towards the solution, we have to find adjoint of A. The adjoint of A, how it is found? Now it is also really a new topic for us. So again I have the third note, which is leading diagonal plus chance and minor diagonal sign change. The required value of adjoint of A is 1, 2, minus 3 and 1. After changing its plus and sign, we get the required value of A as this. Now finally, by the condition of x is equal to A inverse b, what do we get is we have to now put the formula of A inverse. The required formula of A inverse is 1 by A determinant into adjoint of A into b. Now, by putting the value of a determinant adjoint of A and B, what we get is 1 by 7, the matrix A and matrix B. Now we have to multiply the adjoint of A with B, where we have to multiply the first row with the first column and second row with the second column. After simplifying it, finally we get the required value of x and y as 1 and 2. We have got the same value through graphical method and also through matrix method. We must analyze it. If we are getting the wrong different values, then it may be the wrong. Now lastly, we are going to solve it through Cramer's rule. While solving through Cramer's rule also, we have the same two equations. The required equations are x minus 2y equals minus 3 and 3x plus y equals 5. Now, while solving it, we must not forget to write it in language like here we have x minus 2y equals minus 3 and 3x plus y equals 5, which is going to be solved by Cramer's rule. Now, most challenging part is just arranging it in the coefficients of x, y and constant. It is the most challenging part. If we do not arrange it properly, the whole solution may be wrong. While arranging the coefficient of x, we must analyze the coefficient of x component in the equation. Here in the equation, what we have the coefficient of x is 1, 3 and coefficient of y as minus 2, 1 and finally constant as minus 3 and 5. Now, after arranging, what we have to focus on the determinant. Here it is given D, which stands for determinant. Now we have to compose a new kind of matrix from the coefficient side of x and coefficient of y. After composing a new matrix, we have to find the determinant. As we have previously discussed, that defining determinant is through leading diagonal minus minor diagonal, and the required value of D is 7. Now, secondly, what we are going to do is finding determinant first, and it is shortly given by D1. Here again we have to form a new matrix, but it is the most difficult part. Most of the students are doing wrong in this place. So I would like to request you all friends not to be confused in this portion. We are forming a new matrix here, but how we are forming is that we are replacing the first column where we kept x in the previous determinant. We are keeping the constant column in the first column. And secondly, what we are keeping is coefficient of y. After keeping these two, we have to find the determinant of y. I think it is really challenging and you have not understood it, so I am repeating it once again. While finding determinant 1, what we have to do is replace the first column by the constant column. And the constant is where minus 3, 5 and second column is composed of coefficient of y, which is minus 2 and 1. Now we have to find the determinant, which is done by leading diagonal minus minor diagonal. The required value of determinant is 7 here. Thirdly, we are going to find determinant 2, which is shortly given by D2. Here also we are going to compose a new matrix, which is given by coefficient of x and constant column. Here we can see the constant column is not, here we can see the constant column is replaced in the second place where previously we had y. So the matrix is composed of matrix is composed of coefficient of x and constant column. So the required determinant here is 14. Now we are almost at the end of the solution. Here we have to find the required value of x and y. So how to find it? It's really not difficult. We have an easy formula here, that is d1 by d, and we have to put the required value of d1 and d, and similarly for y also we have d2 by d, and we have to divide it and find the value of y. Finally, what we get, the value of x and y is 1 and 2. In the three methods which we solved here, we are getting the value of x and y as 1 and 2. From the examination point of view, we can solve through any method in the examination if the method is not particularly mentioned in the question, but if mentioned, we have to solve it particularly. Now, I hope that you all have understood what I have discussed today. As we know, it is the most difficult portion in grade 10, and it is very important too. So from the examination point of view, it is really important, and I believe that you have learned something from this. It is really very important for us to learn something like this. And in this pandemic situation where the people do not have access to the facilities, we are digitally trying to help you to teach you something. Hope you are going to learn something from our video. If you like it, like this video, please like it, comment it, and share it. And for more videos, we are going to come back again with new topics, something new and different. So please subscribe it. Hope you all are going to like this video and my explanation too. Thank you.